Jaime will tell us how to exploit the full power of LLM to create a new and better future of work, and what could be the role of recommender systems in this process. Thank you very much.
Yeah, thank you. That's great. So yes, thank you. It's it's a real pleasure to be here, in part because of the sort of long history and value of the work that this community does. And I'm particularly excited to be talking with you right now as generative AI is really changing the way that we think about recommender systems. They're changing the way we think about how you interact with digital information. They're actually changing the way we think about how we do research as well. I was thinking with all those words created for reviews about the opportunity there is there to make the reviewing and knowledge dissemination process better. So I'm going to talk a little bit about generative AI in the context of productivity, which is adjacent to recommender systems. So there's pieces that are similar and there are pieces that are different. And I think it's valuable in part to highlight some of the research challenges that we have at Microsoft around this, because I think the recommender system community can actually teach us a lot, and hopefully it will inspire some research that both helps the recommender system community as well as something that can cross domains and help other communities as well. So pretty much right now, whenever you attend a talk that has anything to do with large language models, you get some sort of history to start the conversation off. And I think that's a reflection of how foundational this shift that we are in the middle of right now is. And so this graph behind me, this is one we use a lot at Microsoft, and I like it because it actually represents an entire millennium of history. Often we think a little bit shorter, but this is going back from the year 1000 all the way up to today. The graph represents GDP for the world in real terms over that period of time. And one of the things that it really highlights is that GDP growth is accelerating, and it's accelerating in particularly in relationship to technology, and in part due to the work that we're doing. So you see, for example, from 1800 to 1900, you see 4-time growth in GDP, and in the last century, you see a 20-time growth in GDP. And you can certainly expect to see AI really serve to boost the world economy, boost GDP, change the way that we're thinking about things. And I think we probably, especially because there's a lot of folks from industry here, really feel that acceleration right now. There's a great quote that I like from the CEO of Shopify that is, "Today has been a great year in AI," and I think that sort of captures that acceleration. So looking historically is awesome because it helps us see trends, it helps us understand the impact that things like technology have on the world. But one of the things that's interesting as we look forward is we're not just observers. It's not just an observational study to try and understand and learn stuff. I don't know if am I too close to these microphones? There's some feedback, but I'll stand over here. But so looking forward, one of the things that's really cool is we actually have this opportunity to shape the world and the trends that are moving forward. And you hear this, for example, when our CEO at Microsoft, Satya Nadella, talks about the current moment. He actually situates the work in the context of computing research. When we announced M365 Copilot in the spring, for example, he talked about Vannevar Bush and the Memex and how we think about information. He talked about Doug Engelbart and all of the work that he did with the mother of all demos, reimagining how we interact with computers. He talks about Mike Weiser and the work that he's done on ubiquitous computing. And so we should know that the research we're doing as computer scientists is impactful, is shaping the future of this curve right now. But of course, when I think about it for myself, I think about it more locally, my own personal experience with the history that brings us to this current moment. And that really starts with the web. So I know we have a number, and actually probably that's a lot of our experience thinking about recommender systems starts there as well. Not all of you are old enough to remember the first time you experienced the web. It probably just existed for your whole lives. But I really strongly remember the first time I saw a web page. I was in this like dungeon of a computer science lab at my undergraduate institution, and this guy calls me over and he's like, Jaime, come here. And he shows me my first web page through the Lynx browser. And if you remember Lynx, it's like it's text-based. There's not a lot of graphics. You like have to tab around between the links and hit return to follow a web page. And I thought it was really dumb. Fortunately, I didn't think the guy was dumb. I married him, and these are our 4 kids. That's why I have their picture up here. But the thing that really changed my mind about the value of the web and the web content was web search. And it was recommender systems. It's that ability to search and understand and make sense of the information that's out there that really changes the way we think about that. And I was actually so excited about it that I went to work at a company called InfoSeek, which was an early search engine, and then went and did my graduate work in personalized search. And, you know, at that same time, in parallel, I was giving birth to these 4 kids, and you can see they're pretty close in age. So Griffin, who's the one here in the middle, he was born in 2004. He's my oldest. And my youngest, Briar, who's on the right-hand side, was born in 2008. And in that 4-year period, there were a lot of changes to the web and how we access and use information that were really foundational to the way that I think about the world and that I think it helped shape where we are right now. So for one, in 2007, the iPhone came out. I was lucky I didn't have to actually think about whether my kids were allowed to use my smartphone or not, because we didn't even really have them. But so the iPhone came out. The other thing that happened, Azure came out. So the cloud came out at that time. Azure Web Services came out. So we have the cloud and we have mobile devices, computing from anywhere and the ability to access it from anywhere. And what you see then related to that is actually a lot of the kind of the start of the creation of micro content, micro work. So Facebook didn't exist before Griffin, did exist before Briar. It existed beforehand. It was in Harvard, so it was closed. But like as a thing that we could all sign up for, it didn't exist. Facebook, Twitter, Mechanical Turk came into existence in that period. And so what you have fundamentally is this ability to capture and create richer, more interesting types of information. And not surprisingly, you then see the rise of real innovation in deep learning. And the first ImageNet paper came out in that period as well. And so these technological changes, combined with having 4 little kids, shaped my research. I developed this concept of micro-productivity, or basically, how do you take what Mechanical Turk workers are doing, where you take large tasks and you break them down into small pieces? How do you do that for your own personal productivity? And in many ways, you can sort of think of that as like early AI systems. Search engines are really the first at-scale AI system that people have worked with, and micro-productivity was an attempt to extend that. So I did my graduate work in personalized search. I went to Microsoft Research. Was really exciting to get to work with the Bing, sort of came into existence there, got to work on personalized search there, extended it to really thinking about AI and productivity, doing this work on micro-productivity. And then I went to go work with Satya Nadella, our CEO, as his technical advisor. And Satya asked me to take on this role, my current role, which is chief scientist, to think about how to bring all of the research and innovation that's happening in the world at Microsoft Research and in this community and in the other academic communities that we are part of, bring that into our core products. He was essentially asking me to solve the innovator's dilemma for Microsoft. So we have this problem where we have these decades-old products. Word is awesome, PowerPoint is awesome, but they are well-established. People know how they work, they know how to use them, and it's hard to drive change. So I took on this role, and it was pretty scary to try and drive change in these big products, but I had a secret weapon, and that was that I was a part of the research community, and able to draw from this community, able to draw from Microsoft Research to start doing that. But I was pretty new in role, had sort of just gotten started on that, when another big scary thing happened. And you'll remember this, in March 2020, companies and universities and institutions around the world started shutting down following the COVID-19 pandemic. Actually, my last meeting that I had on campus before Microsoft Campus shut down was with Satya. I was sitting there like at 5 o'clock in the afternoon of March, 7th, 3rd, whatever the date was, talking about the importance of research and how important it was that we figure this out in our products. And I walk out of his office, and I go stop by my friend's office, who was right next to him, who's his comms person. And she's like, "That's it, we're sending the mail out right now, shutting down the offices." And so I grabbed my plants and headed home. Made my job even scarier. I mean, everything was scary about that moment. I'm sure you remember. But it was really scary to be taking on a new job with a new responsibility, new functionality, doing something different in this big established company at a time when there was such a significant disruption. And it's useful to know in context that companies, when there is a large disruption, one of the ways that they deal with that is to drive efficiencies. They essentially get really good at what they do when they don't do extra stuff. And so I'm like, okay, they're not gonna, they don't want somebody changing everything out from under them right now. And so I was pretty sure that my role wasn't gonna be needed going forward. But fortunately, there's another way that companies respond to disruption, and that's to lean into innovation. And so it turns out, ironically, COVID made my job easier. Basically took all of that change that we were just talking about, with the cloud and the proliferation of mobile devices and algorithmic advances and artificial intelligence. It took all of that sort of primordial goo that was ripe for innovation, and it provided the spark to really reimagine work, which was what I was there to do. And so researchers from across the company came together and drove what was probably the largest research initiative in the company's history to really respond to that challenge. And I talk about all of this coming up to our current moment in time, where we're thinking about AI, which is much more of an internal disruption that we're driving. This is something that we're disrupting ourselves with integrating large language models into our core products. But it's really a part of this entire arc that gets us there. And I love this book. I don't know if you all know the Hagakure. It's a collection of insights from a samurai from 1700 who essentially told his assistant all sorts of, the way he viewed the world before he died, and then his assistant, after he died, took his insights and published them. And he's got this one line in the Hagakure that I really like, which is, "In the words of the ancients, one should make his decisions in the course of 7 breaths." And that's not like we should be rash and make decisions quickly. It's more one should meditate and think on the decisions they need to make so much so that when the time comes, they're able to make those decisions in the course of 7 breaths. And I think largely that's what we are. We're at a time where things are changing fast, and there's a lot we don't know, but the research that we have been doing over the past several decades puts us in a position where we can make the decisions that we need to make to move forward. I love looking at the word cloud of the kinds of things, and actually it's fun to think about how language models are gonna take word clouds and do a much better job of writing an awesome paragraph that summarizes all of the submissions that there are. But it's cool to get to see where we are and where we are going to go. And so we've probably also, I talked about the first time I saw the web and how that was sort of shocking. we probably also all have an early experience with a large language model that sort of represents a bit of a shift in our mind with, I've been doing AI and AI adjacent research for decades, and I have bets with people that we weren't going to, I didn't think we would be where we are today, when I started out on this. The kind of the emergent properties in current models are pretty shocking. And I remember the first time I saw GPT-4. It was about a year ago, and so this was pre-Chat GPT. This is like everything's very secret and locked down. And I'm driving onto Microsoft campus to meet with Sam Altman, who's the CEO of OpenAI, and Kevin Scott, who's the Chief Technology Officer at Microsoft, and a few others, and to get to play around with GPT-4 for the first time. And I was deeply skeptical. Those of us, with experience with AI, I think we're often the most skeptical of these sort of new models. And I go into this meeting and I've sort of got my arms crossed and I'm like, okay, let's see what we've got. And Sam takes a news article, throws it into the model, and has the model summarize it. And it's sort of like, okay, that's nice. We all see cool demos like that. We've all seen that. But it was then that process of being able to iterate and ask questions and go back and forth and correct the model and have the model figure things out and do it right. It was really transformative. And I had gone in there knowing that it was going to be my job to take this model and integrate it into our products. And I was scared. Clearly, I'm scared a lot. It seems to be a common thing. But so I was scared. I'm like, how am I going to do this? This is hard. We've been trying to, I've been spending years trying to really drive AI breakthroughs in our products. How are we going to do this? And as I drove home from that meeting, I actually had to pull over, and I only live 2 miles from campus, so it's not a very long drive. And I had to pull over in my car, and I just screamed. It was just so shocking and so surprising. And I felt such a responsibility to take these models and do a good job bringing them into our products. And I felt a responsibility to do it in a way that made the world better. And I just felt like what a gift it was to be right there at that moment and have that opportunity. And that began a sprint where I've never seen Microsoft move so fast, a big, huge company, but it was all of the wonderfulness of being a big, huge company coming together and moving super fast. And we announced in March, which is, maybe within 6 months, we announced total reimagination of our core products to incorporate these new models. And one of the things that really stood out in the process as we do that, there's a lot of talk about the models, and the models are interesting and great, and we do research on that, and we should be doing research on that, and that matters. But they're called foundation models partly because they're a platform in which we need a larger ecosystem for those models to work in. And so what I want to talk about right now a little bit is what we're calling enterprise-grade AI. And so this isn't just the world's best models. It is, of course, the world's best models. But it is the world's best models in an ecosystem that allows them to operate at a global scale, where they're up all the time and can be used all the time by people around the world, where they're grounded in your personal data. We talked about personalized search and personalization, being able to ground the model in what you know is important, where they're trustworthy. That means if they're using your model, your data, they need to do that in a secure, compliant, responsible way, and where they're embedded in your workflows, in what you are actually getting done. So I'm going to dive into each of these 4 areas a little bit and talk about some of the research challenges that we're thinking about. But my hope is mostly to spark, we need these things answered, so please do research in this space, but also to spark some creativity and thinking around how to advance these areas even further. So, starting with global scale. Generative models are becoming global, and one of the things that's super cool about these really large models is how well they work in different languages right out of the box. So we pretty much always ship our early AI stuff in ENUS markets first, because you take where you've got some data, you train on that, and then you ship there. That's not true for M365 Copilot. We're shipping in all of our tier 1 languages where there's enough data to train on, the model can actually do pretty well. And what's more, we're doing a ton of research to understand how these models can do well even on low resource languages so that you can start seeing them in other kinds of things too. So here's a list. For example, one way that we're doing this is you can actually take a prompt, translate it into English, run it through the model, translate it back into the language you started and do that. And that can work pretty well. For some languages, it actually improves the outcomes. For other languages, it harms the outcomes. And we're looking at that and exploring that. And you can see, actually, some of the things that you might expect. Some of these languages where translating it improves into English, improves the performance, are the low resource languages. There are also languages that tend to not necessarily use a Roman character set. And so here's some data, for example, showing non-Latin script languages are lagging in performance, and training data size is still really dominant in how things get done. But there's a lot of work happening in that space. It's a good area for us all to be thinking about. Another thing we think a lot about is efficiency. So we need to be serving these models up to billions of people worldwide, and we need to be doing it in a reliable manner. As much as you might be like, oh, well, if Word breaks, it's not that big a deal, we actually have very concrete examples, like Teams goes down, and hospitals can't schedule people for the operating room, and actually has real life or death stakes in this happened. And there's a number of scarce cloud resources, such as compute, such as bandwidth, such as memory. And in order to, Microsoft, what it does to handle these resources around the world is super impressive. And then with language models, we have essentially a paradigm shift in the kinds of workloads that we're having to serve up, and that we're thinking about those in different ways. And probably the biggest fundamental shift there is just the astronomical size of these language models. I mean, we had to reimagine Azure in order to be able to train GPT-4 at the scale that it is. And the inference is also huge. It's expensive. It's big. I've never had so many conversations in my life about GPUs and GPU allocation as I have in the past year. And these workload profiles are changing significantly, and they're changing in real time. As we bring online new experiences, new scenarios, and essentially we have to leverage research to improve the efficiency of these LLM workloads. So we're using this, not only are language models changing the workloads, they're also, AI is a way that we can do a better job allocating work. And so we do a lot of work in AI ops for cloud efficiency. This is an extremely, thinking about how we're going to do skew optimizations and various other things, power capping. There's a lot of work happening in this space. And one thing that's kind of interesting that comes up a lot is actually people worry about the size and scale and cost of these large language models, and we worry about it too. We worry about it from a sustainability perspective and from a efficiency perspective. And the nice thing there is those goals are deeply aligned. The more efficient and the cheaper to run these models can be, the better those models are for the world. We've got a lot of work happening to try and understand sustainability as well. Microsoft has a commitment to be carbon neutral, actually even carbon negative, by 2030. This is an example of an underwater data center, which is just one of the ways that we're trying to explore to bring compute close to where it needs to be, to handle things like cooling in novel ways. So that's a little bit about what some of the things we're thinking about running these language models at a global scale. Now we're going to think about grounding it in your data. So my background is information retrieval. This is particularly close to my heart. Really reimagining what IR looks like. when you're thinking about how do you pull the right information into a language model to get things done. So there's all sorts of new problems. How do we find and search and identify the right information? How do we compress it so it fits in the context window? How do we do that in a privacy-preserving manner? One of the things that's really interesting is this piece right here around how it reduces hallucination. One of the big challenges with these models is that they can hallucinate. Grounding it in context matters. And actually, with M365 Copilot, one of the first things that we did was actually take the model and work on just not even thinking about how you search and pull up information from elsewhere, but just grounding on the information a person's working on. Take the Word document that you're writing and use that to ground it. If you're having a meeting, take the transcript of the meeting that you're having right now and use that to ground the model. And that allows us to start getting these models into people's hands in a way that is more reliable. One of the things that's interesting in an enterprise context, which is largely where Microsoft operates, is that we've thought also a lot about the very complex search problem of different permissions. That I have access to a file, but I might not have access to that file tomorrow if somebody decides to take it away from me. And it's going to be different accesses to information that somebody else has. And one of the nice things about this retrieval augmented generation is actually, because that's not getting trained into the model weights, but it's pulled up dynamically, you can actually change the kinds of information that you're embedding the model in dynamically and in a way that is consistent with ACLs and permission. So RAG allows us to essentially incorporate privacy by design into the models. We're also thinking a lot about what it will mean to start training on private data sets. This is something when you talk to our customers, probably their biggest concern right now is just thinking about how's my data getting used, what gets exposed, what's getting stored in the model. So retrieval augmented generation is great for that. We can assure them that their data is following the same permissions that it does any content that they have within their enterprise. But when you start thinking about training, that's going to be more challenging. We're doing a lot of work on differential privacy as well, and figuring out how to do that well. There's all sorts of interesting challenges and trade-offs here to do fine-tuning. Also an interesting thing, because I know this community thinks about metrics and evaluation a lot, becomes quite interesting to actually think about how can you believe and understand the trade-offs you're making around privacy and quality. And so, for example, here we've got a standard ROC curve, and the goal is to get as close to identity line as you possibly can. This particular thing is showing an example of, the red line is performance when you don't do any privacy mitigations, and then it starts playing around with, okay, you can scrub the data for PII, personally identifiable information. You can also use differential privacy approaches, and you can essentially get down to this green line, which is quite close to identity. So there's all sorts of opportunities to think around privacy. I think that's very relevant too in the context of recommendation systems. And then, of course, being trustworthy doesn't just mean being secure and compliant. It also means being responsible. And so we're doing a lot of thinking around what these models look like and how they work. And, we're thinking about the entire ecosystem. So we'll think about the model, and how do you do RLHF to make the model better, to make sure to kind of handle things like bias that might be embedded in the model. How do you do monitoring around the model to watch for challenges and issues that come up in use? How do you provide the right prompts and guidance to the model and sort of have the right ecosystem? And then actually, how do you design the user experience even to help people? Hallucination's a great example of that. How do you design a user interface that slows people down a little and helps them go look and think about the content they're seeing? How do you provide citations and allow people to check that the model is producing the right thing? And one of the things that I found really interesting about the work that we've been doing is how much this new generation of models is surfacing new challenges for us to be thinking about as well. In some ways, I would say like bias is like classic responsible AI challenge. You know, we know that we need to not have bias in our data sets. We need to be looking for bias in the output that we're producing. But hallucination is a new topic that we're thinking about a lot more. Prompt injection is another example of something that we're thinking about differently. And you know, in order to build good products, we need to be thinking about all of these challenges fundamentally. I also think an enterprise context is interesting here as well. In that we often think about consumer products, you know, how our language model, ChatGPT is a great example of us sort of interacting with a consumer product. In an enterprise context, it's really one of the things that we think a lot about is admin controls and how do we actually empower our customers to be making the decisions. We're just data processors. We're just there to help them use the data they want. We want them to understand and see the challenges and the trade-offs that they're making. But they might look quite different than you would think about in a consumer context. Oh, sorry, I was behind. You missed the lovely words saying what I just said. So all of this, then when we've got all of this, it's not useful if you have to go access the language model somewhere else. You need it embedded in your workflow. So we've been building essentially the Copilot stack, which allows the model to start surfacing in situ, and are doing a lot of research to study and understand the impact that large language models are having on people's ability to get things done. And that research is just starting to emerge, but you should expect to see a lot of that in the coming months. We have, for example, a paper that we published on GitHub Copilot, which takes a language model and helps people code better. And you find that developers produce 56% of their code using GitHub Copilot and find it makes them more productive. I mean, these are just huge numbers in the way that it's changing the way people get things done. And one of the things that I think is really interesting is if you think about Microsoft's products, and actually all the products, many of the products that we use, they have a lot of domain expertise built into it. And it's actually often a complaint about Microsoft products. It's like too many bells and whistles. Excel is Turing complete. But I couldn't use it to create any arbitrary program. I can barely create a pivot table, you know? But when we can start unlocking all of that deep knowledge that has been built in by experts into the products using natural language, becomes a real opportunity to take all of those bells and whistles and all of that functionality and actually make it useful. So one of the things that we're doing also a lot of work around is domain-specific languages. So for example, there's the Office domain-specific language that is enabling people to interact with Excel or Office or PowerPoint or any other of our products using that. So essentially this is in the same way that GitHub Copilot translates natural language into code, we can essentially translate natural language into code that our applications can start. And actually I saw a bunch in the word cloud. There was also the word graphs. There's a lot of interesting stuff about translating. As you start thinking about working with structured data or graph data or other kinds of data, there's a lot that's going to need to happen there as well. It's a really interesting area for research moving forward. So those are the four big things that we think of as making up enterprise-grade AI. And I want to spend a few minutes now reflecting on what all of those things, when they come together, what do those things mean for work? You know, that's sort of like the table stakes, the stuff that we need just to be able to start working in productivity contexts. What does it mean when we want to start thinking about how knowledge work changes? And one of the things that I think is particularly interesting is Microsoft's a document company. Historically, we have created documents. That's what we do. We help you create and share and use documents. But all of a sudden, knowledge is embedded in conversation. And that's actually conversation with a language model, so conversation with your computer, but it's also human-to-human conversation. We were talking about the rapid shift to remote work. Now, many of our meetings and our conversations with other people are digitally mediated as well. And that's going to mean a real shift in how we think about knowledge work. So a large part of any conversation, including the conversation that you have with a language model, is comprised of something that psycholinguists call grounding. So grounding is sort of the process where you're mutually coming together to a shared understanding. And then typically what we do is after we're done grounding, we arrive at some grounded content. So we might have like a fun break. Actually, you come to this conference, we're doing a lot of grounding, and we're talking, and we're sharing information, and we're figuring stuff out. And then you might take all of that and turn it into a trip report, or turn it into your notes. That's the grounded content. And historically, the grounded content is actually more useful than the grounding content. But one of the things that's really interesting about language models is it's making it possible to start pulling knowledge out of the grounding content instead of having to go to the grounded content. It actually makes the conversation in and of itself useful. And so then it starts really becoming about like, how do you set people up to have great conversations? Because if you can start taking the knowledge that's in that conversation, it's all just about like, how do you maximize all the insight that a person's gonna bring to the table? And you know, what's cool is you can actually start doing that using language models as well. Like, how do I prime you? We know that you can prime somebody to like to influence the way they think. How do we prime you in the best way to bring the best information? One of the things, kind of an analogy that I like, is to think about maps. And if you think about maps are actually an amazing technological innovation that takes spatial information and puts it into a form that we can then start reasoning over, and like it allows us to create geopolitical boundaries and do path planning and all sorts of interesting things. But the interesting thing is my kids can't read a map. They don't know how to read a map, and you know why? Because they have Google Maps, and anytime they're going anywhere, they'll be driving along and it'll be like, oh, turn left here. They don't need to actually go to the information. That information is then surfaced in situ so that they can react to it. So you can start thinking, not just are we able to capture that information, but we're actually able to surface the information to help people bring their very best. And so we're doing a lot of studying right now. I've got a battery running low. But it looks like that's fine. So I don't need the confidence monitor. As long I'll just look back here. We're doing a lot of studying right now to understand what's showing up in the chat logs. What can we learn from that? You know, we do not, pretty much the thing we can say we expect the most is we don't expect people to be using these large language models in ways that we expect. And you even start to see this a little bit when we look at like the Bing chat logs. We've incorporated language models into Bing search. And you know, so the people go to that with the context of thinking they're searching for information, but people are using Bing chat to do content creation and summarization and a lot of these actually richer productivity tasks that language models actually afford that better. So we're doing a bunch of analysis. This is just start. You should expect to see a lot of really interesting research in this space come out in the future. This is just like one interesting example. You know, I was talking a little bit about how we could like start taking all of the abstracts for the papers that were accepted at RecSys and summarize it. You can do that with chat logs as well. It's essentially an opportunity to create collective intelligence. You can take all of the chats that people have that are successful, and then you can start saying, what made these conversations successful? So that we can learn lessons to help other people have successful conversations with the language model. And so this is all generated, like whether or not a conversation was successful, and then what were the tricks that people used to make that conversation, all generated by the language model. And so this becomes, and you probably have seen this, because like every social media site I have is like prompt engineering tips and tricks. This is the language model figured all that stuff out on its own, and even some new interesting things. So you can get that for things that you can do. things that you can't do. It's actually super useful too because this is dynamic, so you don't need to when you have a new model, you can start generating new tips and tricks and understanding it in new context. I'm actually really excited about the idea of doing prompt translation across models as well. And in some ways, you can start actually thinking about prompt support as the new ribbon for the language model. That's one of the big challenges we see with customers as well. Is you give them an empty text box, you don't know what to do with it. This was really hard with web search too, actually. It's kind of fun when you look at the early query log analysis and how people search changed over time as they started learning. Actually, search queries, web search queries got shorter and shorter because the shorter queries performed better. Now we're having to teach everybody to start asking, providing more context and asking longer kinds of questions. But there's this real interesting opportunity to start thinking about how we use, how we help people have good conversations, and actually particularly because human-to-human conversation is not the same as a human-to-model conversation. And there's actually all these sort of components, complex things. You're like, please describe this, give me 3 different answers and choose the best one. There's very complex kind of prompt chains that you use with a language model. How can we make that fast and efficient for people to do prompt translation for a person's prompt into something the model will do a good job with? Huge opportunities there. So I guess, I kind of want to take all of that and summarize it to say the work that you're doing is really important right now. And we look at that millennia of change and how technology has accelerated the GDP growth of the world. And you should know the work you're doing is just going to accelerate that even more. This is a really important time. We're lucky to be right here, right now, doing this. And I think in particular, we're lucky to be scientists. And I love that 2/3 of the people here are from industry, because we need our business leaders to be leading like scientists as well. And so we have this huge opportunity to lay the groundwork. And I think when I think of what it means to be a scientist and lead like a scientist, I've sort of got 4 things that I take away. One is obviously developing hypotheses, developing metrics, and then testing and iterating. That's sort of the obvious part. And I highlighted in particular, I think the work happening in this community around metrics and evaluation as key. But there's other important points too, that we are here learning from each other. Science is about reading and building on the state of the art and not inventing new things. And things are just too complex and too challenging for us to invent everything again. Science is also about sharing our findings. And we do that partly so other people can build on those findings. But we also do that for validation. That's why the peer review process is important. Having other people challenge and debate and question what we're doing is fundamental to make sure we don't get stuck in a bubble. And then also, science is about considering the externalities and the long-term impact of what we're doing. Because the stuff that we're doing right now is going to have real impact on the world to come. So thank you for the work that you're doing, and thank you for having me.
Thank you very much. Thank you very much for your great talk. Thank you.